So let's consider another example here. This time we've got the integral of sine cubed cosine to the fifth. They're both odd powers, and since they're both odd powers, that does mean we can convert either a pair of sines here to a pair of cosines and leaving me with the singleton sign, or we can take two pair of cosines, cosine to the fourth, and convert them into 1 minus sine squareds, two of those times, okay, leaving you with a single cosine. Now, that's actually just a little bit more work. We could do it either way, but I'd like to go with the one that's just slightly easier. So let's do that. So we're going to convert, as I said, to the sines. So in other words, we're going to consider this as a sine squared of x times the other sine of x, and we'll keep all the cosines grouped together. And now we're going to take our sine squared and replace that with the 1 minus cosine squared. And so we now have the integral of 1 minus cosine squared of x times our singleton sign, which we're going to want for our dw, and then our cosine to the fifth of x dx. And we could either multiply through or we can do our substitution. Either order works. I think I'll just do a substitution right now. So our w is cosine. The dw will be a negative sine of x dx. And so that dw, there's our sine of x dx. That'll become then a negative dw, right? So this now is going to become a 1 minus w squared. Okay. This cosine to the fifth is now a w to the fifth, and as we said, the sine of x dx now becomes a negative dw. I'll pull the negative out front of the entire integral, and we'll have that. And now we'll multiply through here, so we have negative integral w to the fifth minus w to the seventh dw, and now it's very easy to anti-differentiate. We have a negative 1/6 w to the sixth, right? And then minus 1/8 w to the eighth plus c. And I think we'll just distribute that negative sign in there. And finally, the w's are really cosine. So it's a negative 1/6 cosine to the sixth of x plus 1/8 cosine to the eighth of x plus c. And there's our answer. If we did choose to, instead of changing two of the sines over, if we instead decided to change 4 of the cosines into 1 minus sine squared for each pair, we would have had an answer that instead of involving a whole bunch of cosines, we would have had an answer involving a whole bunch of sines. They would have been equivalent based on various trig identities. But that was the easiest way to go, so that's the way we did it.